Okay. Hello, my name is Professor Overton. Some of you have me for the classes and or have had me previously, so hopefully you know what to expect. But I have this little slide presentation to go over some of the basics. What are we going to be covering in this class? Functions, sets, relations, proof techniques, propositional and predicate logic, counting, and a variety of other topics. Basically, this class is going to mathematically formalize common sense. It's not difficult concepts, it's just mathematically formalizing how we think and how we use logic to come to conclusions and reason and that sort of thing. So we use functions, sets, relations to quantify concepts and use propositional and predicate logic in proof techniques. And I include the chapter on counting because I think it's an important topic to cover when it comes to computer science when you start dealing with very large numbers. Counting, knowing how to count efficiently in a computer can save a lot of time when you're talking about billions or trillions of numbers or items. So these are the topics that we're going to be covering. What you need to know. You should take notes. More on that in just a little bit. You should ask questions. Don't be afraid to ask questions. People say that the only stupid question is the question that's never asked. I disagree with that statement. There is such a thing as a stupid question. I'll give you an example that actually happened to me. I was in a grocery store and I was by the sodas, and this lady came up to me and asked me, straight face, completely honest, asked me, how many are there in a 12-pack? The question that answers itself is a stupid question. Okay. I almost answered a dozen, but I figured that might fry your brain. I don't know. Anyway, ask questions. You might have a question that somebody else has, but is afraid to ask. So go ahead and speak up. Don't worry about any repercussions or being shrugged off by me or anything like that. I'll take questions seriously. If I'm not explaining something clearly, let me know. Communicate with me. If you have issues, got to miss class, whatever, let me know. I'll work with you. I do not see students as an annoyance that I have to deal with in my job. You are my job. So, if I don't work with you, I don't feel like I'm doing my job, and I can no longer have my job if I don't do my job. So what I will do is I will allow notes on quizzes and tests. Those that have had me before know that I cover typically a lot of material in a semester. It is completely unreasonable to expect you to memorize it all. So allow quizzes and tests to use. You can use notes on them. A professor that I had many moons ago put it this way: he didn't know of any job that involved physics. It was a physics class where you didn't have reference available, and that was pre-internet. but now you have the internet, and you can have references and all that sort of stuff when you get out into the working world. So why should it be any different in class? But there's a difference. I do not allow laptops, tablets, that sort of thing to be used on tests. They have to be printed notes. Now I can be lenient, but only so far. I don't need ChatGPT answers. I want your answers from your reasoning, that sort of thing. So they will be paper tests and quizzes and printed notes being able to use. Yeah. Well, yeah, that's on paper. Yes. Yeah. Yeah. Good point. Paper notes, whether they're printed off of a computer or handwritten, doesn't matter. I mean, if you want to print all the slides from the book and have those, there's hundreds of slides, but you could have them if you wanted to, if you printed them all out. Trying to go through them during a test might be cumbersome, but it is allowable. As you can see, I record my lectures. Generally, they are available on YouTube the following day. I will post a notice, an announcement on Canvas when the video is uploaded to YouTube, and include the link in the announcement. Currently, I'm having a little issue with software, so it might take a week or two to get these initial lectures up on YouTube, but they will be coming. And if you miss a class or you want to refresh or supplement your notes, you can go back and view the videos on YouTube. I will also be available outside of class. As it said in the first slide, I'm an adjunct professor. I think it said that on the first slide. Adjunct means part-time. I'm typically here full-time hours anyway. So I'm generally on campus by 8:30 in the morning. I don't have any classes until noon. So I'm available during that time. Come by my office. If you have a question or just want to chat or get a cup of coffee, feel free to come by. But I will be available outside of class. What makes up your grade? Attendance. More on attendance in a little bit, but I do consider it an important factor in determining somebody's grade. Are you willing to show up? I have had students complain about their grade, and I go look at their attendance record, and it's like, if you showed up only 48% of the time at a job, you wouldn't have a job anymore. So don't complain about this grade. You're only there less than half the time, you're not going to get a good grade. 20% quizzes, 25% homework, and 45% in-class exams. That includes the 45% includes the midterm and final grade exams. Let's see here. Homework will be assigned on a chapter basis, and it will be due before the quiz or exam on the chapter. If you have access to Canvas, you can see where the homeworks have already been posted. You can start on them anytime. If you want to get ahead and read the slides and advance at your own pace, feel free. All the slides that I'm going to be using are in the Files section of Canvas. So you can download those and view them in PowerPoint or Google Slides. And If you have a laptop, you can follow along. Sometimes I use the slides on the smartboard, sometimes I don't. Depends on the chapter. The slides were generated, I believe, in PowerPoint. This program for the smartboard doesn't display them properly, and there's a lot of typos in them, so I don't really like the slides all that much. So I'll do my own notes on the board for a majority of the class. But the slides are available to you in the file section of Canvas. What you should be doing this semester: attend class. Like I said, if you're here less than half the time and you get a bad grade, don't complain. You know, if you need to attend class to get the material, be able to ask questions, take tests on time, that sort of thing. Take notes. Taking notes helps you absorb the material, and you will be allowed to use them on quizzes and tests, like I said. So take plenty and clear notes so you can reference them later. Ask questions. If you don't understand a concept and don't ask the questions, I will think you've gotten it. If you need it reworded, expressed a different way, let me know. I can rephrase. I can try to come up with an example to use to show the concept, that sort of thing. See here. Why is it important to take notes? Processing. When you take notes, you're condensing the lecture material down into written or typed form. That takes some processing on your part to understand it, so you know what to condense, what to leave out, what to leave in, that sort of thing. Just the act of taking notes helps you grasp the material better. You would be better off taking notes and then throwing them away on the way out the door than you would by just sitting there listening. Taking notes helps you process the information that you're being given. Organization. Organizing your notes is important because you have the reference on the tests. How you organize your notes is going to vary from person to person. So how you take notes and organize your notes is going to be different from how he takes his notes. So relying on copying other people's notes may not be very useful because you don't know how it's organized. What did they leave out that they got that you didn't, or that you wouldn't have left out? Or keeping things organized so you can reference them easily and efficiently is important because they are allowed on tests. Like I said, if you take notes on a tablet or a laptop, print them out before class. I am pretty ticky about people using laptops and tablets on tests. I don't like it. I don't think that there will be some math, so you can use calculators, but that's, I think, going to be in the last chapter covered in the semester. But calculators are allowed. What I will do: allow notes. Like I said, I will record the lectures, and I will be available. I'm usually on campus Monday through Friday. If I'm not in a class, I'm usually available to help. If you need help on a weekend, something coming up on Monday or something, Monday or Tuesday, and you need help on a weekend, I can generally be available on the weekends. Just let me know. Communicate with me. I will work with you. I don't have set hours that I have to be here, other than my office hours, which are in the last slide. But I'll be, I've stayed on campus until 9 o'clock at night, helping students out before. I'm flexible as far as that is concerned. I am understanding of special circumstances. Disabilities, sports, band, student organizations, travel to conferences, interviews, all reasons to miss class occasionally. Do we have any band members in? Oh, two, okay. Well, band has performances they have to do, sometimes travel for those performances. So, you're probably going to miss a class or two or three. So, I'll be willing to work with you to make sure you stay caught up. If you miss a class because, you have a game, you're a baseball player or something like that, and you have a game in Grambling, you gotta go where especially if you're on a scholarship, you gotta go where the money is. And, that's a perfectly valid reason to miss class. And I will work with you to get you caught up or make up any tests or quizzes. Travel to conferences. I highly recommend traveling to conferences. They're good opportunities to network, potentially get internships or job offers, depending on where you're at in your matriculation. So traveling to conferences is a great they're great opportunities to see different parts of the country or the world. My first conference when I was an undergrad was actually in Africa. So I was there for a little over a week, and being able to see, not just on some documentary how people lived in that part of the world, but see it firsthand. That type of opportunity doesn't happen nearly as much as it probably should, especially after you graduate and you're out in the working world. You probably have to pay for your own travel, whereas traveling to conferences, a lot of times, depending on the circumstances, other people are paying for it. So get the opportunity to travel on other people's money, take it. There's a saying in research: opium is good. OPM, other people's money, is good. So job interviews or internship interviews, good reason to miss class. Got to go where the money is. Internships are an important part of the education process. You learn tons on an internship, and typically you get paid as well over the summer if you're doing a summer internship. So if you have to miss a class because of job interviews, no problem. Career day, I think it happens a couple of times a year, once in the spring and once in the fall. You miss a class for that, understandable. You're here to get an education, to get into a profession. Career day helps you get into the profession. So, that sort of thing is perfectly acceptable. Any questions? Did I miss anything? Is there anything that I can do in addition to lecturing, recording, being there out of class that can help you in this class. Yeah, I'm open to suggestions. I'm not perfect. I'm not the be all end all of professors. I'm open to suggestions on how to improve. I'm not. I've taken suggestions from students before, and they worked out great. So why not? Just because I'm the teacher and you're the students doesn't mean I know in every case more than you guys do. There's always something to learn. If a day goes by and you don't learn something, it's a wasted day. So anyway, finally, office hours. I don't know why I neglected to put my office location on the slide, but Monday, Wednesday, Friday, 12 to 2. Supposed to have official office hours. Those are the official office hours, but I'm here typically a lot more than that. So come by my office. I am actually 3D printing a sign for my door to indicate where I'm at. It'll have a little thing for in my office, please knock, in class, in a meeting, do not disturb, that sort of thing. So go to my office. In a few days, that signage will be printed and painted and all that sort of stuff, and you'll know how to get a hold of me or where I'm at any particular time. This is my personal phone number. Please don't abuse it. Nobody has yet, but don't want to start now. If you do need to reach me in an emergency type of situation, you can text me. Calling is probably not a good idea because unrecognized numbers, I assume, are telemarketers or scam callers or whatever. So I don't typically answer unrecognized numbers. But if you text me, let me know who you are, and all that sort of stuff beforehand. Yeah, I'll answer it. But again, like I said, don't abuse the access there. But yeah, any office location. For those of you that don't know, you know where Miss Seaton's office is upstairs, or the desk, the administrative assistant, secretary, whatever you want to call her. It's in that office suite there, number 237. It's the second door on the right. Dr. Humos is the department chair, his office, and then my office. So easy to find. More of this information and more will be in the syllabus. They changed the format of the syllabus, and it's like 17 pages long. So I'm having a time of it getting all the information put together and put in the format that they want and all that sort of stuff. But when I do get this syllabus done, it will be posted to Canvas in the files section. So look for that in the coming week or two. So, but that's it for my opening little salvo there. We're going to go ahead, and since this is an hour and a half long course or section, we're going to go ahead and start on chapter 1, discrete structures. Speaking mathematically is the first chapter. I'll let people get their stuff out and notes ready. All right. We're going to start off with variables. You've had, one would think at least, algebra, college algebra up until this point. So you know what variables are in most mathematical in contexts. But a variable used to represent something. Okay, it consolidates things down, simplifies things. You don't want to write out 1,000 digits of pi, you use the pi symbol, the variable pi, the Greek letter pi. So a variable is a placeholder for statements, numbers, or Boolean expressions. We'll get into what Boolean expressions are if you haven't taken a course that is, or are currently taking a course that describes what a Boolean expression is. But a variable can be used to represent, basically Boolean expressions are true-false statements, true or false statements, true or false values. But it can be a placeholder for a statement. Like, if you attend class, then you get a good grade. You can express that as A and B. If A, then B. A equals attend class. B equals good grade. We'll get into what the arrow means later on, but basically, if it basically means an if statement. So that's if A, then B. If attend class, then good grade. You substitute the value of the variable in to make the complete statement. You could substitute a different statement for A and B. If you change A to eat rotten food and B to get sick, if A then B still has the same truth value to it. So a variable can be different values depending on the circumstances. So when these variables are used when you may not know what the value is. That's the most common use of the variables in your math classes. So when you don't know what the value of an variable is at the time, leave it as a variable. You can still work with it. Like algebraically, you can solve for a variable or find the relationship between two variables. Or there might be multiple values or infinite values. Like y equals 2x plus 3. Infinite number of values for x and y. The equation gives a relationship between the two, but x and y have infinite values, infinite number of values, forming that's the if I'm recalling correctly, the equation for the slope-intercept for a line in a Cartesian graph. And this is where we're going to work with them a lot. Makes an argument general. Like like this one here. If A then B, A could be different things and B could be different things. But you can manipulate the if A then B in a general fashion regardless of what the values are. So you can make an argument more general using variables. Okay, let's see here. Are there numbers, some examples here. Are there numbers with the property that the sum of their squares equals the square of their sum? So, the sum of the squares equals the square of the sums. So you would say, you would have a squared plus b squared equals a plus b squared. So you can translate numbers, translate words into variables. For asking a question. In this case, you're asking a question, are there numbers that satisfy this equation? Or you can make a statement. Given any real number, its square is non-negative. So for all R, R squared is greater than or equal to 0. For all R. Make a statement and make it concise and more general at the same time. with variables. Now there are some important mathematical statements. The universal statement. We just had one. Universal. A certain property is true for all elements in a set. True for all elements in the set. A conditional statement had one of those as well, with a if A then B. So the conditional statement if one is true, the second one must be true. Then there is the existential statement. An existential statement is a statement where there is at least one thing for which the property is true. There exists an element for which it's true. So those are the three basic types of mathematical statements. Now there are ways that you can combine these. So you can use a statement can have characteristics of more than one, like the I'll let you get caught up on the writing here. But the universal conditional statement a statement that is both universal and conditional. So best given with an example. For every animal A, if A is a dog, then A is a mammal. It is universal because it's every animal A. If it is a dog, then it is a mammal because every dog is a mammal. So it's conditional. If A is a dog, then A is a mammal. and it's universal for all A, for which those are true. So universally, all dogs are animals, or all dogs are mammals. And it's conditional. If A is a dog, then A is a mammal. That's the didn't write this up here. Universal conditional statement. Now the universal existential statement has two parts. The first part says that a certain property is true for all objects of a given type. So property is true for all elements. The second part asserts the existence of something. Something exists. So, an example of that remember from I think algebra 1, if I'm recalling correctly. For every real number, there is an additive inverse. So every indicates universal, and existential has an. It indicates the existence of something, in this case, the additive inverse of the given number. Now, this could be written in several different ways, some formal and some informal. Informal would be like this. Every real number has an additive inverse. More formal would be, let's see here, see if I have enough space to write this. It's for every real number R, there is a real number S such that S is the additive inverse of R. It's a little bit more wordy, but it's very clear, formal, and that's part of what we're going to be learning here is, like I said, this is mathematically formalizing common sense. Stuff that you already know, like you already know that there's from Algebra 1, there's an additive inverse to every real number. So, in formal terms, for every real number r, there is a real number s such that s is the additive inverse of r. That's how you would mathematically formally state it. We'll get into how you symbolically write the same thing, but another example. How can you restate the statement, every pot has a lid? How would you restate that informally? Every pot has a lid. All pots have lids. This is basically saying the same thing. More formally, for every pot P, there is a lid L. So there you go. Now another variety of statement is the existential universal statement. The existential universal statement, again, has two parts. The first part, something exists. The first part says something exists. The second part says that the object from the first part satisfies a certain property for all things of a certain kind. Okay, and then the second part is satisfies a property. Okay, and what does that mean? Let's give an example here. There is a positive integer that is less than or equal to every positive integer. So there exists a positive integer such that it is less than or equal to all positive integers. Is that statement true? Is it true? Anybody? No? Yes. Yeah? Yes, it is true. Why? Well, give me an example. What positive integer would be that? Would that be? One. It is less than or equal to all positive integers. All positive integers start at 1 and go up from there. This 1 is less than all those or equal to the 1 at the beginning of the sequence. So it is true. How could that be reworded in a less formal manner? That's a little bit formal. Less formally, how could that be worded? I'm sorry? Yeah. So, but keeping with the structure of the statement, not without stating the number, some positive integer is less than or equal to every positive integer. Yeah. But it is existential. Oh, whoops. There exists indicates the existential. There exists something. And it is universal because it satisfies the property for all. It is less than or equal to all, the all being important, all positive integers. How are we doing on time? Let's see here. What about there is a person in my class who is at least as old as every person in my class? I'm going to write this one out. You've all taken Cal 1, right? So you understand limits, theoretically? Let's see here. Let me make sure I get this right. The limit of a of n as n approaches infinity is L. It can only be defined using phrases that are universal, existential, and conditional. So it's for every positive real number E, there is an integer n such that for every integer n, little n, if n is greater than big N, then A of n is greater than negative E, and A of n minus L is less than E. Does that look familiar from Cal 1? Kinda, maybe. Already forgotten it by now. But for every, that's universal, there is existential for every, universal again, if n is greater than big N, so on and so forth. So it is universal, it is existential, and it is conditional. So you can combine the different types of statements in different ways depending on the need of the argument or statement that you are trying to express. Let's see here. I think we will wrap it up at this point. The next section is going to be the language of sets. We will take care of that on Thursday. Let's see here. Give me one mark here. The language of sets, and I think, let's see here. Relations and functions. Yeah. We'll get that. Like I said, this is mathematically formalizing common sense. These are statements that you've used, types of statements that you've used in making arguments, describing things, that sort of thing for years, all your life. It's just a matter of mathematically formalizing it so you can draw other conclusions and make clear arguments for whatever topic that you're dealing with. But yeah, so that'll be it for the day. Have a good day. See you on Thursday.